Okay, so good afternoon, everyone. Wait a minute. Okay, give me 1 minute. Okay, okay, let's start the class. So I just sharing my screen. Okay, as you can see on the screen, this is about the course contents, and we already done with the chapter 1. Okay, we done with chapter 2, right? And then we done with chapter 3. So today we're gonna talk about chapter 4. Okay, and don't be forget that the topics that we're gonna cover in the midterm exam is gonna be chapter 1, 2, 3, and 4. Okay, 4 chapter is gonna be covered in midterm exam. Today we're gonna talk about chapter 4. Chapter 4 we're gonna learn in chapter 4 we're gonna talk about the theory of IS and LM model. Okay, IS and LM model. This chapter is very important. It's like a foundation. Okay, we're gonna learn IS and LM in chapter 4, and again we're gonna learn it again in final exam chapter 5 and also chapter 6. Okay, so it means that if you don't understand it, okay, you may have a problem in midterm exam, and also you may have a big problem in final exam, because ISLM in chapter 4 is like a foundation to learn in chapter 5 and chapter 6. Okay, so today we're going to talk about chapter 4. Okay, let's start. Okay, chapter 4. Okay, chapter 4 is going to be the story about IS and LM model. Okay, so IS, the first one, the word IS is come from investment and saving. On the other hand, the word LM is come from liquidity, okay, and money. Okay, liquidity is, liquidity is come from liquid. It's like a water. Okay, so in economics, money is like a water. Money can flow from one place to another place. Okay, that's why we call it as the liquidity. Okay, liquidity and money is the same thing. Okay, so today we're going to talk about IS first. Okay, before we talk about IS curve, you need to know about the theory of Keynesian clause. Okay, first. So today we're going to talk about the theory of Keynesian clause, which is going to be the basic for the IS. Okay, yeah, the Keynesian clause. Okay, as we learned before, in macroeconomics we focus a lot on GDP, right? Okay, and in macro GDP we use variable Y. Okay, and for the variable Y as a GDP we have three main meaning. The variable Y can be total output. The variable Y can be total income. And finally, the variable Y can be total spending, right? Okay. So for the Keynesian clause, okay, for the Keynesian clause, we're gonna focus on total spending. Okay, we're gonna focus on total spending. However, in the theory, they just use the name TE. Okay, in the theory, they use the name TE, and TE is come from total expenditure. Okay, expenditure and spending they have the same meaning. Okay, so basically total spending and total expenditure is the same thing. Okay, so the graph of Keynesian clause is gonna be look like this. Okay, it's gonna be look like this. On vertical is gonna be TE as a total expenditure, on the horizontal is going to be variable y. For the other meanings of y, on horizontal is going to be y as the meaning of total output and total income. Okay, total output and total income. Okay, so in the Keynesian clause, okay, on the vertical we have total expenditure, on the horizontal we have the less of the meaning of y, total output and total income, and then we're gonna have 45-degree curve. The nice property of 45-degree curve is every point on the 45-degree curve, the vertical and the horizontal is always equal. For example, point A, point B, and point C. Point A, if the vertical, let's say TE1, on the vertical like TE1 equal to 100, on the horizontal, Y1 is gonna be equal to 100, same value, okay? Point A, okay, TE equal to 100, Y as a total output and total income also equal to 100. Point B, if we have TE2 equal to 200, it means that Y2 should be equal to 200, same value. Point C, if you have TE3 equal to 300, it means that you're gonna have Y3, which is equal to the same value, 300. Okay, so what does it mean? That every point on the 45-degree curve, it means that it's represent that total expenditure gonna be always equal to Y, okay, as a total output and total income. Okay, you can consider total expenditure as a demands, okay, demands, okay, because when you're spending the money on something, this is what you want, okay, and you can consider the total output on the variable y as a supply, okay, because supply is about to produce something, right? So every point on the 45-degree curve, okay, total expenditure equal to y as a total output. So it means that demands always equal to supply. Okay, you can think like that. So this is the graph. Okay, next one we're gonna talk about TE. We're gonna go into the detail. Okay, about TE. Okay, as I mentioned before. Okay, TE is come from total expenditure. We learned it before in the previous chapter, right? Okay, total spending. Okay, total spending in the economy. Okay, they come from, okay, first household sector. When household sector spending on something, we call consumption as a Z. When business sector spending the money on something, we call I as the investment. When the government spending the money, we call G as a government spending, right? And in this chapter, we assume that we're gonna focus only in the closed economy country, okay? So the total spending or the total expenditure for the closed economy is come from consumption, investment, and government spending. So in the end, I can write down the equation of TE as TE equal to C plus I plus G. Done. This is what I have, okay, for the total expenditure equation. So what's so good? Okay. So look at the first elements of TE, okay, for consumption, okay, consumption C. We learned it before. We learned about consumption equation before, if you still remember. Consumption equation C equal to A plus B YD, right? YD is a disposable income. So actually YD is equal to income after tax. So in the consumption equation, you consider Y as the income, okay? Your consumption based on your income. So disposable income YD equal to income minus tax or Y minus T. So you put everything you know into the equation. You have C equal to A plus B and Y minus T, like this. Okay, you can easily rearranging the equation, multiply B inside the bracket. You got C equal to A plus BY minus BT. Okay, this is what you have. Done. You have consumption equation. And then I want to draw the graph of consumption. On the horizontal is Y, but this time I consider Y as a total income. Okay. On the vertical is going to be the spending. Okay. This is going to be consumption, the spending of household sector. Okay. If I want to plot the graph of, if I want to plot the line of the consumption, how are we going to do? Okay. The way I'm going to do is I need to find the starting point. For example, somewhere here, the starting point. The starting point can be calculated by if y equal to 0. C is going to be equal to A minus BT. This is a starting point, A minus BT. Okay. After I got the starting point, I want to know how the line, okay, how the curve of the consumption, how it look like. Okay. I want to find the slope. Okay. Slope. In order to find the slope of any line, okay, how to do is we use the mathematical formula delta vertical over delta horizontal. In the graph, the vertical is going to be C, on the horizontal is going to be Y. Delta is like a derivative, right? Calculus, just partial derivative of C respect to Y. What I get from the main equation is I got minus B. No, I got plus B. This is my, okay, this is my slope. Slope always positive. Don't be forget that B that you learned before is equal to MPC, marginal propensity to consume. Okay. Since I know that the slope of the consumption curve is positive B, so I can write down the curve like this. The slope is equal to B. If income increasing by 1 unit, people gonna consume more by B unit. Okay, so the slope is equal to positive B. This is the consumption curve. C. This is how it look like. So what's so good? Okay. Next one. After I know how the consumption curve look like, next one I want to know how the total expenditure curve look like. I coming back to the main equation. Total expenditure equal to C plus I plus G. Consumption, investment, and government spending. I put everything I know into the equation. TE equal to C. C is a consumption, right? Consumption equation is A plus B Y minus T. Put it down. Then I have this equation. I can easily rearranging the equation, multiply B inside the bracket. I got BY minus BT. The rest is the same. Rearranging the equation again, I put the big bracket, A minus BT plus I plus G close plus BY. This is what I want. This is the main equation of the total expenditure, right? Then I can easily drawing the graph on the right. On the horizontal is Y as a total income. On the vertical is going to be TE as a total expenditure. First, to draw the graph, I want the starting point. In order to find the starting point, we use the same trick. If Y equal to 0, TE is going to be equal to A minus BT plus I plus G. This is what I want. This is a starting point. For example, maybe somewhere here. This is A minus BT plus I plus G, the starting point. Next thing, I want to find the slope. Slope equal to delta vertical over delta horizontal by doing math, partial derivative. Okay, I got plus B. Same, just like before. Okay, this is MPC, marginal propensity to consume. So now I know that the curve is going up to the right, just like the consumption curve. Okay, the slope is if Y increasing by 1 unit, total expenditure will be increasing by B unit. This is total expenditure curve. Okay, total expenditure curve slope is depend on the value of B. Okay, slope is depend on the value of B. So after I can find the curve of total expenditure, next one, I'm gonna bring the total expenditure curve, put it together with the 45-degree curve and find the meaning of it. Okay, so I go into the next slide here. Right now, I'm gonna construct the full Keynesian clause model. Okay, I want to construct a full Keynesian clause model. So I'm gonna write out the graph here. On the vertical is TE, on the horizontal is Y as a total output and total income. Okay, then I have 45-degree curve, which is TE always equal to Y. And then I'm gonna write down total expenditure curve. Okay, yes. The starting point is A minus BT plus I plus G, right? This is total expenditure curve that is come from C plus I plus G. Okay, this is what I have. And you can see that the total expenditure curve and the 45-degree curve intersect to each other. The point that two curves intersect to each other, we call it as the equilibrium point. Okay, the equilibrium point, what does it mean? The equilibrium point, the point that total expenditure intersect with 45-degree curve, is mean that on the horizontal Y, let's say Y star, and on the vertical TE, let's say TE star, they're gonna have the same value. Okay, they're gonna have the same value. For example, if Y star equal to 1,000 millions, total expenditure gonna be equal to 1,000 millions, same value. As I mentioned before, TE total expenditure is just like, okay, TE total expenditure is just like a demand. Y as a total output is just like a supply. Okay, so the point, the equilibrium point, okay, the equilibrium point on the horizontal, this is like a GDP total output equal to 1,000. This is like a supply. On the vertical, total expenditure equal to also equal to 1,000. This is like a demand. So the equilibrium point is the point that represents demand that is equal to supply. Okay, so far so good. Okay, equilibrium point is a point that demand equal to supply. The total output always equal to total expenditure. No more, no less. Okay, no more, no less. So in conclusion, okay, in conclusion, the I have some question in chat. Why is it plus B? I got a negative. Okay, wait a minute. I'm gonna go back. Okay, so let's go back to this slide. Why you got minus B? The slope is equal to delta vertical over delta horizontal, right? In this case, delta TE over delta Y. Okay, if you study mathematics 1 in the university, the calculus, when you do the partial derivative, when you do the partial derivative of TE respect to Y, what you get? You get plus B. How you get minus? Okay, if you get minus, it means that, you know, you have the problem about calculus. Okay, same thing with the consumption. I take the partial derivative of C respect to Y. This is C, this is Y. So what I get when I do the calculus, I got plus B. So far so good, Mr. Pawat. Are you okay? Okay, good. Okay, you got it right. Very good. This is just a basic mathematics that you learn from high school. Just a basic calculus. Okay. Going back to our slide here. Okay. So in conclusion, the equilibrium point is going to be the point that total expenditure intersect with 45-degree curve, which represent the meaning of demands always equal to supply. Total expenditure always equal to Y as a total output. The point other than this, okay, the point other than this, for example, the point on the right, I'm going to use the red color here. y1, let's say, or the point on the left, I'm going to use the blue color, let's say y2, okay, okay, y1, okay, y1, the red color, y1, what does it mean? y1, okay, you can see that y1, this one, at the 45-degree curve, this is high, okay, 45-degree curve represent supply, okay, supply, okay, this is the number of product you can produce. On the TE curve, okay, which is lower, this is represent demand. This is how much money you're gonna spend, right? As you can see here at Y1, the red color, the supply is higher than demands. Okay, they have the gaps in the yellow color. So what does it mean? Supply greater than demand, what does it mean? Our economy, we produce too much. We have excess supply problem. We produce too much. We have a lot of product that we produce a lot. We have a lot of product that nobody want to buy, right? Okay, we produce too much. We have a lot of product that nobody want to buy, which is called excess supply problem. So what the economy gonna do in the long run is we're gonna reduce our production. We're gonna produce less. When we produce less, Y as a total output gonna moving to the left until it's going back to Y star as the equilibrium point. On the left hand side for the blue color, Y2, okay, the 45-degree curve represents supply, okay, the point that you're going to produce. On the total expenditure curve, total expenditure represents demands. As you can see on this one, demand is higher than supply, okay, you have excess demand problem. People want to buy a lot, but we produce, the product we can produce is not enough. Okay, we have excess demand problem. It means that we produce too less. Okay, we need to, what the economy gonna do is the whole economy, we need to produce more. When you produce more, Y as a total output gonna moving to the right until it's going back to the equilibrium point Y star again. Okay, so it means that either your economy stay on the right or either your economy stand on the left. In the end, in the long run, they all move to the equilibrium point. If they're moving to the equilibrium point, everything is going to be stopped changing because demand already equal to supply. So that's a good. Okay. Next one, okay, to make you more understand, let me give you example for the real number. Okay, let me give you the number. Okay, then you can calculating. We can calculating together with the real number, and then it's gonna make you more understand about these topics. Okay, so here we're gonna talk about math. Okay, using the real number. Okay, for example, I'm giving you that we have the consumption equation like this: C equal to 100 plus 0.8 YD. I assume that T tax equal to 50. I as an investment equal to 200, and G as a government spending equal to 300. Okay, this is all the information they're gonna give it to you. Okay, like this. After you know all of this information, okay, after you know all of this number, you can easily calculating for the total expenditure equation. So what they're gonna do is they're gonna start with total expenditure equation, TE equal to C plus I plus G. Okay, like this, very easy. Okay, starting with the main equation, TE equal to C plus I plus G. So what I'm gonna do next is I'm gonna put everything I know down into the equation. C equal to 100 plus 0.8. YD is income after tax, Y minus T. T equal to 50 plus I 200 plus G 300. That's it, very easy. Put everything together, okay? 100, 200 and 300, combine it together. What you get? You get 600. You can multiply 0.8 into the bracket. You got 0.8 Y. 0.8 multiplied by 50, you got 40. In the end, TE equal to 560 plus 0.8 Y. Okay, this is what I want. Total expenditure equation. I can use this equation to drawing the graph. Yeah, on the vertical is TE, on the horizontal is Y. What I want first is the starting point. In order to find the starting point, I assume that if Y equal to 0, TE is going to be equal to 560. So I know that the starting point is somewhere here at 560. So far so good. Okay. And next one, I want to find the slope. The slope is delta vertical over delta horizontal. What I get? I want to do the calculus partial derivative of TE respect to Y. What I get? I got 0.8. So now I know that the curve, they're going to have the positive slope going up to the right. Okay, they're going to have the positive slope going up to the right. If Y increasing 1 unit, total expenditure will be increasing 0.8 unit. This is total expenditure curve. So far, so good. Okay, easy mathematics just from high school. Okay, if you have any question, feel free to asking me. Okay, you're gonna learn about this more in detail in the other class in mathematics, in mathematics econ, math econ. Okay, you're gonna learn more. Very difficult than this. This is just an introduction. Okay, after I can drawing the total expenditure curve, the next thing I'm gonna do is I'm gonna try to find the equilibrium point. So here is gonna be about the calculating of equilibrium point. Okay, equilibrium point. So let me show you on the graph first. Here, I have TE on vertical, I have Y on horizontal, I have 45-degree curve. Okay, so far so good. Wait a minute. Okay, and then every point on 45-degree curve TE equal to Y. And then this is TE curve. Okay, which is come from equal to C plus I plus G. Equilibrium point is somewhere here. I don't know what is Y star is going to be. The starting point is 560, let's say, for example. Okay, so far so good. Okay, and then what I want to find out is what is the value of Y star at the equilibrium point? What is the value of TE star at the equilibrium point? Okay, I want to find the value of the equilibrium point. As I mentioned before, at the equilibrium point, demand is always equal to supply. I'm gonna start with this idea. Equilibrium point, demand always equal to supply. Demand is come from total expenditure. Supply is come from total output as a Y. So I'm starting the equation with this. Okay, total expenditure equation, I bring it from the previous slide. TE equal to 560 plus 0.8 Y. Bring it here, put it down. 560 plus 0.8 Y equal to Y. Rearranging the equation. Okay, 560 equal to Y minus 0.2 Y. Oh, wait, 0.8 Y. And then 560 equal to 0.2 Y. Okay, 0.2 is just 2 over 10, right? Easy. Multiply by 10 over 2 equal to Y. 2 divided by 10 equal to 5. Then Y star at the equilibrium point equal to 2,800. This is what I have. So I know right now, I know that at the equilibrium point, Y star equal to Y star equal to 2,800. And total expenditure also equal to 2,800. Demands equal to supply at the equilibrium point. Okay, so far so good. Not only equilibrium point, I can also calculating every point I want. Okay, I can also calculating every point I want. For example, if Y equal to, let's say, 1,000, Y1, 1,000, how it's gonna be if I change to the green color? Okay, Y2, if it's equal to, let's say, 4,000, how it's gonna be? Okay, I can easily calculate this. Okay, starting with Y1 at 1,000. Let me keep this one. Okay. Y1 and 1000, 45-degree curve. This is supply. Okay. Supply equal to 1000. How about demands? How demand gonna look like? Okay. If you want to find the demand comes from total expenditure, right? Okay. Total expenditure equal to 560 plus 0.8. You put 1000 into the equation. Then you got 560 plus 800. TE equal to 1360. You know demand is 1360. So you can easily find the gaps over here. You can easily find the gaps over here. Demand is higher than supply. You have excess demand equal to, okay, 360. Easy calculating. Okay, you can find the excess demand problem at Y1, okay, equal to 360. Moving to the green color, if Y2 equal to 4000 at the 45-degree curve, again, 45-degree curve, total 45-degree curve is going to be equal, okay? At 45-degree curve, you have supply equal to 4000. For the demand curve, okay, what you're going to get, okay? You just put the number Y2, which is equal to 4000, into total expenditure equation. Total expenditure equation, TE equal to 560 plus 0.8 Y. In this case, Y equal to 4000. Write it down. So then you got 560 plus 0.8 multiplied by 4000 equal to 3200. So TE here in this case, if Y equal to 4000, TE going to be equal to 3760. Demands equal to 3760. So you know that from here, the gaps over here, supply is greater than demands, okay? Excess supply equal to 240. Okay, easily like that. You can actually find everything. Okay, in the exam, I can asking you to calculating everything. This is easy to do. Okay, so also good. Okay, should be easy. Okay, not difficult at all. Okay. After you know how to find the equilibrium point in the Keynesian clause, okay, which is easy. The next thing I'm gonna showing you is if some number change, how it's gonna affect the graph, how it's gonna affect the equilibrium point. Okay, if some number change. So starting with the detail about mathematics that I gave you before. Consumption equation equal to 100 plus 0.8 YD. Tax equal to 50. Investment equal to 200. Government spending equal to 300. Okay. This is all information you have that we did together. Okay. And then I'm going to drawing the graph that we did it together. On the horizontal is Y. On the vertical is TE. You have the graph like this. Starting point is 560. Slope is equal to 0.8. This is like TE equal to C plus I plus G1. Okay. So if something change, for example, the government decide to spend more. If the government decide to spend more from 3,000, from 300 to 400, how it's gonna be? Okay, the government, okay, decide to spend more from 300 to 400. Okay, when the government spend more like this, we're gonna use this as a delta G equal to plus 100. Delta in mathematics is about changing. So the government changing their spending, okay, by adding 100 more from 300 to 400. So we can call it as a delta G equal to 100, okay, because they're increasing their spending 100 more. If the government increasing their spending from 300 to 400, everything is going to be changed. We can calculating everything again, okay, starting with the same, okay. So we're starting with the main equation, total expenditure equal to C plus I plus G, simple like that. Consumption is 100 plus 0.8, YD is Y minus T plus I, and plus the new G. The new G right now is 400. Calculating everything again, TE equal to 700 plus 0.8y minus 40. TE finally equal to 660 plus 0.8y. This is a new equation for the total expenditure. Okay, this is a new equation for the total expenditure. The changing is about the starting point. Okay, the starting point change. You can calculate it. If y equal to 0, TE going to be equal to 660. The starting point change from 560 to 660. You see that? How about the slope? Delta TE over delta Y equal to 0.8. The slope is the same. The slope is the same. The starting point change going up. It means that the whole curve shift up parallelly. The whole curve shift up parallel. This is a new TE. TE equal to C plus I plus G2. Okay, the curve shift up parallelly. Okay, the gaps that the curve shift, okay, here equal to the gaps here equal to delta G equal to 100. Okay, the government spend more by 100. The curve of total expenditure curve shift up parallelly. Okay, the slope still the same. Okay, this is how it affects the curve. So far so good. Okay, should be easy. Next thing is, how about equilibrium point? Okay, how about equilibrium point? Okay, let me drawing the graph first. Y, O, and TE. I have 45-degree curve. TE equal to Y. This is the O curve. TE equal to C plus I plus G1. Equilibrium point 1, Y star 1, which is equal to 2,800. The starting point is 560. The government spend more, so then the whole curve shift up. This is TE equal to C plus I plus G2. The starting point change to 660. Okay, the gaps here, okay, equal to delta G equal to 100. Okay, the equilibrium point moving to the right, as you can see, from E1 to E2, and you will see that the new Y star should be increasing a lot. The new Y star should be increasing a lot. Okay, but the problem is we need to calculating what is the value of Y2. Okay, we need to calculating the value of Y2. So to calculating is very easy using the same, okay, the same way that we did before. Equilibrium point. Okay, again, equilibrium point is come from the point that demand equal to supply. Demand is total expenditure. Supply is Y as a total output. So I'm gonna put the new total expenditure equation down, which is we just did it together here. TE equal to 660 plus 0.8Y. Put it down. 660 plus 0.8Y equal to Y. 660 equal to Y minus 0.8Y. 660 equal to 0.2Y. 0.2 is like 2 over 10, right? 660 multiplied by 10 over 2. 10 over 2, this is like a 5. So Y star equal to 3,300. So now I know that this is 3,300. Okay. So what is interesting is the government spend more for 100. However, GDP increasing for more than that. Okay, GDP delta Y increasing from 2,800 to 3,300, increasing for 500. You see that? Okay. Let me write down into the detail over here. The government spend more from 300 to 400. Delta G equal to 100. But the GDP increasing from 2,800 to 3,300. Delta Y, the changing of Y equal to 500. If you put delta Y over delta G, what does it mean? The government spend more for 100. And as the consequence, the GDP increasing by 500. This is 5 times. Okay, 5 times. The government spend more for 100. However, in the end, the GDP increasing 500. This is 5 times. We call it, we have the name, we call this situation as a multiplier effects. We call it as a multiplier effects. Okay. The government spend more for the small number of money. However, the GDP increasing in multiple. That's why we call multiplier effects. Okay. GDP increasing in multiple many times compared to the original spending. Okay. So the next thing is, if I want to find the mathematical formula for the multiplier effects, how are we gonna do? How 5 times come from? Let me showing you here. Okay, to derive the multiplier. To derive the multiplier effects mathematics solution. So you're gonna starting with total expenditure equal to C plus I plus G. Simple like that. Okay. I put everything I know into the equation. C equal to A plus B. YD is Y minus T. Plus I and plus G. Like that. Rearranging the equation. A plus BY minus BT plus I plus G. Rearranging the equation again. TE equal to A minus BT plus I plus G plus BY. Done. This is what I want. Okay. Next one, I want to find the equilibrium point. As I mentioned before, equilibrium point is a point that demand equal to supply. TE equal to Y. Total expenditure equal to total output. I put the TE equation inside this equation. A minus BT plus I plus G plus BY equal to Y. A minus BT plus I plus G equal to Y minus BY. A minus BT plus I plus G equal to 1 minus BY. And finally, Y equal to 1 over 1 minus B. Multiply by A minus BT plus I plus G. This is the equation I want. Okay, this is the equation I want in the ends. Okay, after I got this equation, this is the equation that derived from the equilibrium point. Okay, you can write down as a Y star. Okay, the GDP at the equilibrium point comes from this equation. If I want to find the multiplier effects, starting with the first one, the multiplier effects of government spending, delta Y over delta G. If the government spend more, how the GDP going to be increasing in multiple ways. Okay, if the government spend more, how GDP is going to be increasing in multiple ways. Delta Y over delta G. For the mathematics, basic calculus, delta is like a derivative, okay, partial derivative of Y respect to G. What you get, this is from high school, math 1, okay? You do the partial derivative of Y respect to G, what you get? You get what that stay in front of G. What is stay in front of G? You will see that in front of the big bracket is 1 over 1 minus B. 1 over 1 minus B have to be multiplied to everything in the big bracket, right? 1 over 1 minus B have to be multiplied to A, multiplied to minus BT, multiplied to I, and multiplied to G. When you do the partial derivative of this one, what you get is you get 1 over 1 minus B. That's it. This is Okay, the multiplier effects of the government spending. You can also find the multiplier effects of investment. If the business sector invests more, how GDP going to be increasing in multiple ways. Same thing, do the partial derivative of y respect to I. Partial derivative of y respect to I, what you get? You get everything that stay in front of I. What is stay in front of I? Is 1 over 1 minus b. Same thing. See that? Next one, you can find the multiplier effect of tax. If the government changing the tax, how it's going to affect the GDP, right? Delta is a partial derivative. In this case, partial derivative of y respect to t. Where is t? T is here. What you have in front of t is minus b and 1 over 1 minus b. Together, you get minus b over 1 minus b. Simple like that. This is a multiplier effect of tax. Are you okay, everyone? Everyone, are you okay? This is just a simple mathematics from calculus. If you are not okay with this, you have a big problem, okay? So you can see that all of the multiplier effects mathematics formula is about b. They all have b in the equation. 1 over 1 minus b, 1 over 1 minus b, minus b, and 1 minus b. They all have b in the equation. Remind you again that b is equal to MPC. What is MPC? MPC is a marginal propensity to consume. Okay, marginal propensity to consume. By using the human language, what is MPC in human language? Okay, MPC or B is come from delta C over delta Y. In human language is when your income increasing, how you gonna increasing your consumption? B is a percentage, is always in the number between 0 and 1. Okay. For example, if B equal to 0.8 or MBC equal to 0.8, it means that when your income increasing by 100, you're gonna consume more by 80. Very simple. Or when your income increasing 100%, your consumption gonna be increasing for 80%. If the value of B is high, it means that people in your country love to spending the money on consumption. If the value of B is low, it means that people in your country, they consume less. So it means that they love to save more. Okay. So the value of B or MPC represent the behavior of the people in your country about their consumption and their saving. Okay. And the behavior on their consumption have a lot of effects on the whole economy. For example, if I showing you to compare, for the comparison, I showing you the case of USA and the case of Japan. For example, people in USA, B or MPC equal to 0.8. American people, they love to spending the money. On the other hand, for the Japanese, okay, Japanese people, they love to save, B equal to 0.5. Okay, so how is it affect the whole economy? Let's see. In USA, when the government spend the money, this is the government, maybe they spend 100 more, just like in our example. When the government spending the money, okay, the money the government spend gonna become the income for the other people, right? For example, if the government spending the money to build the new road, okay, the money gonna flow into the company that built the road, right? It's gonna become the income of the company that built the road. When the government spending 100, okay, it's gonna become an income for Mr. A, for example. In USA, Mr. A, they're gonna keep the money for 20 and they're gonna spend it out for 80 because MPC equal to 0.8. When Mr. A is spending 80 is gonna become the revenue or the income for Mr. B. Mr. B gonna keep it for 20% and gonna spend it out for 80%, which is equal to 64. 64 going to become the income for Mr. C. This is how the money flow around the economy. Okay, this is how the money flow around the economy depend on MPC or the value of B. On the other hand, for the case of the Japanese, okay, the Japanese government may be doing the same, spending 100. 100 become the revenue for Mr. A. But in Japan, people normally spend 50% of their income. Okay, so they're gonna save 50 and spread it out for 50. 50 gonna be the income for Mr. B. Mr. B gonna keep 50%, which is equal to 25, and spread it out for 25. And 25 gonna become the income for Mr. C. So you can see here that the money that move around the Japanese economy is less than USA, because people in Japan love to save more than spending. You see that? The number of the money that's going to flow around the economy depend on the value of B, or the marginal propensity to consume. This is very important. How important? How this one affects the multiplier effects. Going back to multiplier effects of the government, okay, delta Y over delta G equal to 1 over 1 minus B. The formula that we derive it together, okay. For the case of USA, B equals to 0.8. For the case of Japan, B equal to 0.5. Put it into the equation, the formula 1 over 1 minus B. In USA is equal to 1 over 1 minus 0.8. Which is equal to 1 over 0.2, right? If you multiply 10 by 10, you got 10 over 2, which is equal to 5. The multiplier effects in USA equal to 5, which means when the government spend more $1, the economy gonna growing $5. Compared to Japan, okay, 1 over 1 minus B equal to 1 over 1 minus 0.5 equal to 1 over 0.5. If you multiply 10 by 10, you got 10 over 5, which is equal to 2. You seeing that? In Japan, when the government spend more 1 unit, the economy gonna be growing only 2 units or 2 times. The multiplier effects in Japan is lower than USA. Everyone, are you okay? Are you all right? Okay, this is very important. Okay. Okay, I hope you understand it. Okay. Next one. Okay. I'm gonna talk about the other multiplier effects. Based on, if I assume that B or MPC equal to 0.8, okay, we have 3 multiplier effects, right? That we did it together. Okay. Based on this number, we have multiplier effects of government spending, delta Y over delta G equal to 1 over 1 minus B. We have multiplier effect of investment, delta Y over delta I equal to 1 over 1 minus B. We have the multiplier effect of tax, delta Y over delta T equal to minus B over 1 minus B. So what you can see here is multiplier effects of the government spending and investment is the same. They have the same formula, which is equal to 1 over 1 minus 0.2. Oh, wait. 1 over 1 minus 0.8, which is equal to 1 over 0.2, which is equal to 5. Multiplier effects of the government spending and investment equal to 5 times. If the government spend more, or if the business sector invests more, the GDP will increasing 5 times. Okay. How about tax? Minus B over 1 minus B equal to 0.8. You got minus 0.8 over 1 minus 0.8. You got minus 0.8 over 0.2. You got minus 4. Minus, this is minus. It's a negative relationship. It means that if the government tax less, going down, GDP, the whole economy gonna going up, negative relationship going up 4 times. Okay. So what you can learn from here is what you can learn from here is if you focus on government fiscal policy. Okay, when the economy is bad, if you are the government, you want to know which one is better between spending more or tax less. Which one is better? Spending more or tax less. Okay. If you're spending more, if you are the government, you're spending more, the multiplier effect is 1 over 1 minus B. If you tax less, the multiplier effect is minus B over 1 minus B. And you can see that spending more is higher. The multiplier effect is higher than tax less. You see that? Okay. So that's why many countries decide to spend more other than tax less. For example, in the case of Thailand, COVID-19, we have COVID-19 crisis, right? The government spent a lot in these 2 years, right? If you go into the restaurant, we have, in Thailand, we callคนละครึ่ง, right? Half and half. You pay half, the government pay the other half. The government want you to going out, right? Spending the money. Thailand government, they have the policy called travel together. They try to convince Thai people to travel around the country, right? If you travel around the country using this program, you pay 60%. The government help you to pay the other 40%. Same thing here, increasing G to stimulate the economy. Okay. So far so good. Okay. Last one. Okay. I'm showing you the graph. Okay, on the horizontal is Y, on the vertical is TE. You have 45-degree curve, TE equal to Y. You have, this is like TE1 equal to C plus I plus G, equilibrium 1, GDP Y1 star. Okay, so this is the conclusion. Okay, if the government spend more or tax less, or the business sector invest more, all of this gonna make total expenditure increasing. Total expenditure curve gonna shift up from TE1 to TE2. Okay, the number of the money that you spend more equal to the blue gaps over here, which is small. However, the consequence of it is going to make the equilibrium point moving to the right from E1 to E2, and the GDP going to be increasing a lot. Okay, here, a lot. Larger than the spending that you increase. This one we call multiplier effects. Okay. GDP going to be increasing higher than the total expenditure that is increasing. That's why we call multiplier effects. On the other hand, if the government spend less or tax more, or the business sector invest less, all of this gonna make total expenditure gonna going down like this, TE3. Okay, and then total expenditure curve, total expenditure gonna be going down like this on the vertical gaps. However, as a consequence, the equilibrium point gonna move to the left to E3. GDP gonna be lower a lot in multiple way, in multiplier effects. So you can see that here and here is larger than here. Okay, because this one we have multiplier effects. So far so good. Okay, so far so good. This is all we have. Okay, so today we completely done with the Keynesian cross model. Okay, before we go, I'm gonna remind you again that we're gonna have the midterm exam on Wednesday, August 17th. Okay, from 9:30 in the morning to 12:30. Okay, you're gonna have 3 hours to do the exam. This is gonna be on-site exam. If you are Thai student, if you're living in Thailand, you're living in Chiang Mai, you need to come to Econ Building, Chiang Mai University, to have the exam. Wearing the student uniform, bring your pen and pencil, no calculator. Okay, you don't need to use calculator. Okay, only international student. Okay, who cannot come to Thailand. You have to prove. For example, if you stay in China, you cannot come to Thailand, you prove that you stay in China, you're going to have online exam. Okay, same day, same times. Okay, and you have to open the camera all the times to avoid cheating. Okay, so the exam is gonna be, of course, the exam is gonna be writing exam, no multiple choice. Okay, writing exam, no multiple choice. You're gonna have to draw a lot of graph to explain. Okay, you have to drawing a graph. You may need to do some calculation, some equation solving, and you need to write down the explanation. Okay, as you can see, we learn many graph, we learn many theory. You have to understand all of it. All of my exam is come from my lecture, so make sure that you fully understand my lecture. Okay, the graph is very easy to do, easy to predict about my exam, because the graph only going in 4 direction. If it's not going up, it's going down. If it's not going to the right, it's going to the left. So make sure that you understand all of the case. Not only the case I teach you, but the case that I didn't teach you also. Try to do it. Try to do it, practice by yourself at home. Okay, that's it. So today we're gonna stop here. And this Friday, no class. This Friday is a national holiday, no class. We're gonna see each other again on next Tuesday. Okay? Any question about exam? Any question about lecture? Very good. Bye-bye. See you.
Thank you.